just go over these carefully so you know what to expect, and then when you're doing this tomorrow, kind of know what's expected on another one that's very similar but not the same. But the questions are always the same. Basically is, do you understand the meaning of all the math that you're using? So when you get down here, you know it's going to ask you is, what does the slope of this mean in context of the question? What does the y-intercept mean? So if you have those questions in mind before you begin, okay, on the graph, plot all possible combinations of double-doubles and fries that cost no more than $20, and describe all these possibilities. If you want to preview all of it, read the question, so when you start the problem, you're already kind of thinking about it. So when you get to here, you already know, like, okay, I'm going to have to describe all these possibilities. How am I going to use that? I'm not going to go through and give you the actual words to use for the descriptions. So I don't want you to think like what I write down is the right answer. This is where that math goes into that realm where it's, well, as long as you describe everything correctly, it's correct. No matter how you do it, it's correct. Use units, and that will usually be enough. Okay. So here, if you only bought double-doubles, how many could you, how much could you buy if you spent the entire $20 and you guys all came up with? 5 double-doubles. So make sure you use, proper sentences and everything. Don't just say 5. Okay.
Where do we put 5 double-doubles?
Just do what I tell you. You could buy.
Try to put 5.
I've already told you exactly what to do, and now you're asking questions. Can I do something else? So, know the answer already. I'm giving you clues that they don't want a fragment. They don't want, the shortest possible way of saying it. They want full sentences as if you're explaining it to somebody. To know how to communicate this, and not just get an answer and say it's 5. So write it out exactly what you'd say and what you would do. Okay, same thing here.
You can buy 10 right. No bag. You can't buy 10. That's true. No, but
Yeah.
you can buy 10.
Okay, but 10 fries.
That has it's a bag.
Yeah, I didn't really put it
Does it matter?
You're gonna buy one fry for $2.
At McDonald's, what do they give it to you?
It doesn't matter.
So, yeah, you could, if you wrote this out, okay, you could buy 10 fries. You might read that and say, well, I'm not buying 10 fries. And then you can throw in bags or orders or whatever. But I want you to use the language that you want to use. I don't want you to just copy it and say, oh, it's this. This is the answer. But have it make sense in real life. Okay? There's no template of the right answer. Okay. Now, going on to the graphing. Now, chances are you probably like to do a table before you graph it. So another advantage of reading all the questions is that it doesn't penalize you for doing them out of order. Okay, so let's go ahead and create a table first. And fill in all the values for this. And the caveat or the validation criteria would be that whatever we come up with has to equal exactly $20. That's what 1 and 2 ask. Spent the entire $20. And we're going to assume for now that we're in Oregon or Nevada and there's no tax. So usually we don't use X and Y in the actual problem. We use a variable, a letter that's more specific to the actual problem. So instead of double-doubles, we'll use D. And instead of fries, we'll use F. But later on, make sure we write our equation using D and F, not X and Y. But we do this all the time, like when we have stuff with time, we use T instead of X, and so on. Okay? So how many well, number 1 says if you get 5 double-doubles for $20. So that means there are 0 fries, 0 over fries. But what if you only had 4 double-doubles? Okay, how many orders of fries could you get? 2. And if you had 3 orders of fries, 4, so it'd be $12 plus $8. And then if you had, and now you can see the pattern. Well, it's going down by 1, it's going up by 2, and you can finish it up. So if I have 2 double doubles, I can order 6 orders of fries. Now these are all the combinations that add up to $20 exactly. And this is the mathematical part of it, that there is a pattern to this. It's just not random, like, oh, it's 7 burgers and then 2 fries, and then it's randomly 3 burgers and 10 fries. There's actually a systematic pattern if you list them all down. And often the pattern is there, but you don't realize it until you're listing all the possibilities. So the next thing is to go ahead and graph that, and since there's a pattern for all these, we expect to see a similar pattern when you graph it. So the double doubles is going down by 1, and the fries are going up by 2, and it could be vice versa. Depends how we graph it. So we have fries where kind of like the y value is. So that means this is going to be my fries, and D is kind of where the x value will be. All right. And now you have to look at your domain and say, well, I'm only graphing 0 through 5 double doubles. But if I just count 1, 2, 3, 4, 5 squares, you're only going to be using a very small part of this graph. So space it out a little bit. Let's count, just for neatness and clarity. Just go every other so we use up more of the graph. With the fries, though, we can't go every other because this is only 15 boxes. So we just have to count by ones. I'm going to count by ones, but only label every other one. So 1, 2, 3, 4, 5, 6. Work there. 6, 8, and 10. There you go. And I'm going to stop at 10 because I know that's the highest order of fries. So knowing your domain, knowing your range does help you know where to stop. So plot our points, okay, if we have 5 double doubles B, we can't order fries. So if I order 4 double doubles, I can order 2 fries. 3 double doubles, I can order 4. And now you can see, just like here, that pattern. I can see a pattern here. There you go. So what do all these points represent? If you had to summarize this, you would say something like this. These are all the possible combinations of burgers and fries that cost exactly $20. Now, the question will come up, should you do this? It looks like a nice straight line. Should you do this? No. And the short answer is no, simply because in this certain problem, and it may not be true in the next problem, you have to analyze it and think about it yourself. This point right here, well, connecting these means all these are points. These are all possibilities. These are all realistic. Right? That's what all these points in between. There's an infinite number of fractions and decimals. But what do these fractions and decimals actually mean? So if you take the units into consideration, well, this number right here I'll use, actually, would be like half a double-double. And right here would be like 8.75 orders of fries. And since you can't realistically order half a double-double or 3/4 of an order of fries, that means we should not be connecting these at all because it's not realistic, not orderable. And that's something that you're not going to find in math class. It's just something you have to ask yourself in reality, is this true or not? Does it make sense or not? So we call this a discrete function. That's not something you have to know right now, but when you cannot connect the dots, even though they line up, you cannot connect them because it doesn't make sense, it's called a discrete function. Usually if we're talking about like how long did it take to get this stuff ready, like how long did it take to order get ready, well, it wouldn't have to be just 2 minutes or just 3 minutes. It could be 2 minutes, 5 seconds, 2 minutes, and we'd be having all these fractions. So if there's time, it does make sense to connect it. You just have to look at any given problem and see, well, what makes sense for this one? So we can look at the slope and look at the y-intercept. That's what they're going to ask us in 5. So first, count the slope. You can use any points. We kind of already know it right here. This is like the y, so it's going to go up by 2 and down by 1. So we expect, okay, it's going to be 2 over negative 1. And we do expect a negative because we can see it's going down, right? Okay. Or you can go and count the squares, and this is like all the same stuff we just took a test on. How come this is 2 over negative 1 here, but it's not over here? Okay. So be careful. It's still up 2. Okay, that's up 2. But just because it's 2 boxes doesn't mean it's 2. Just remember down here, we're going from 2 to 1. So that's only negative 1. So it is the same thing. Just like before, if these didn't agree, we did a whole homework on that. If you don't get the same thing from the chart or from just using the skeleton as you get from the graph, one thing at least is wrong. So they all should match all the time. So yeah, our slope is 2 over negative 1, which is the same as negative 2 over positive 1. It just depends on how you do it. Those both equal negative 2 regardless. The y-intercept is 10, and more specifically is 0, 10. So together, we put those together, and we know, like, okay, it's y equals mx plus b for the equation. So using that format, we have y equals negative 2x plus 10. Right. However, remember from the very beginning, we didn't use x and y as our variables. So adjust this a little bit one more time. Instead of y, we have f. And instead of x, we use d for delta. So you want to adjust your equation to match the variables that you defined at the beginning. You know, step 1 on all those word problems that you always see is always define the variables. So you have to use those variables throughout the whole problem. Now, the next two, C and E, are probably the most important part of this entire side. That's when you actually have to say, well, what does it mean? Okay, we got an answer. That's the easy part, actually. What does it mean? Describe what it means. So go back to the slope up here and actually remember, what is negative 2 talking about? Well, that was negative 2 fries. Orders of fries. And the positive 1, the units were double doubles. So what does that mean? So for every 2 order of fries that we lose, we can gain positive 1 double double. Now, mathematically, that should make sense because, well, 2 order of fries is $4, and 1 double double is $4. So it kind of makes sense that if I start at 10 fries, 10 order of fries, if I take off 2 orders of fries, go down 2, now I can add 1 double double. I have enough money. So I took off $4. Now I can add on $4, and we'll still be at $20 total. That's what this means in context. That's what you need to write right here in your own words. I lose 2 orders of fries, then I can afford to buy 1 more double-double. For every 2 orders of fries I don't get, I can afford 1 more double-double. Using some sort of language like that. And 0, 10. What does this mean? Same thing. Double doubles. That's what the X stands for, the D, and this stands for fries. So what does the y-intercept mean? When you don't have any when you don't order any double doubles, you can afford 10 orders of fries. Yeah, 10 bags of fries. But use your own language, use your own words to that effect. But C and E are the most important parts of this little slide when you actually explain that negative 2 over 1 has a meaning and it is, this in terms of the units. All right, so flip it over. Now use the chart and read the question. If you only buy one double-double, how many fries can you buy? Okay, using the chart, yeah. Okay, and use a complete sentence. Okay. So that would be the shortest. You could say I could buy 8 orders of fries if I only buy one double-double. Complete sentences, capitalization, punctuation, spelling do count. Okay. Using the graph number 7a, do you have enough money to buy 3 double-doubles and 3 fries? And how can you tell by looking at the graph? What gives it away? So find 3 double-doubles, that's right here, and 3 fries, that's right here. And how can you tell just by looking at where the dot falls that you can't afford it?
It's slightly under the slope.
So it's below, so we can picture this imaginary line as like, well, everything along this line is $20. So anything below the line, anything that falls below, we know is going to be less than $20. Likewise, if we ask another question like we do in 7b, and the dot is above, we know, well, that's too expensive. That's more than $20. So just by plotting it, you can tell if you can afford it or not. So the next one I believe was, 4 double-doubles and 4 fries. And then when you go up here, okay, 4 double-doubles and 4 fries. Okay, that is above our $20 mark. So yeah, we won't be able to afford that. That's above $20.
$4. Give me this quarter.
So once again, in your own words, go ahead and write that out. Okay, for 7a and 7b, do you have enough money? The first word is going to be yes here. And then, yeah, why do we have enough money? And then here, no, we don't have enough money. And just explain in words. Just how would you say we don't have enough money? Oh, because 4 double-doubles and 4 fries cost this, and we only have this much money, therefore we can't afford it. Using your own words, okay? Using your own words. And lastly, I'll give you a second to finish. Okay. So on your graph, plot all the combinations of double-doubles and fries that cost no more than $20. Okay? So $20 or less. And then in words, describe them. Now this doesn't mean make a table of all the possibilities. It says to plot all the possibilities. It doesn't say to list them like in a table. You're just describing them in general. And I already kind of touched on it earlier. So here, we already know that 3 double-doubles and 3 fries is less than $20. What about here? Is this less than $20?
Yes.
And these are all combinations. So I can have 3 double-doubles, no fries. 3 double-doubles, 1 fry. 3 double-doubles, 2 fries, and so on. All the combinations of 3 double-doubles. Okay. That's still going to be less than $20.
Oh.
Same thing here. 2 double-doubles, no fries. 2 double-doubles, 1 fry. 2 double-doubles, 2 fries. So all these are possibilities. 1 double-double, no fries, 1 double. So these are all possibilities. So this is the first part of number 8. And don't forget these over here. Just 1 order fry, 2 order fries, 3 order fries, and so on. These are all possibilities as well. Don't forget over here. So all these black dots are all those other possibilities. Now, technically it's possible that 0, 0, that wouldn't make sense that you go to In-N-Out and you wouldn't buy anything, right? So keep in mind for your realistic problems that sometimes you include it, sometimes not. Okay, if you're talking about how long it takes to do something, chances are it takes more than 0 seconds, minutes, hours, days, or whatever. So keep in mind realistic problems. If you did this, remember, don't connect the lines, but all of these mean those cost $20. So you expect, well, if it worked for $20, what would all these be? What do all these things cost? Yeah, you can figure that out. You can figure out what all, those two cost. So you can get all the different possibilities that you could spend, and you can see all those have something in common. That's why they're all in a straight line. There's a reason for that. It's not randomness. They don't just kind of come that way because, well, that's just the way it is, but there's a pattern. So describe all that down here. Okay. By the way, where do all these possibilities lie? In relation to $20. So the correct answer would be, well, these are all below. All the points that actually work are below the $20 line. That's how you describe all of these, because these are all the possibilities that cost no more than $20. So you see the description, when it asks you to describe, it's not asking for, even though there's a big space here, it doesn't mean write a paragraph, but it just means that you can write something like all the plotted points are below the $20. And then just go on from there. Again, I don't want to have you copy exactly what it is, but that's a good way of starting. All the points that we plotted that cost less than $20 happen to be below all these points that do cost exactly $20. So it's like less than or equal to $20. By the way, I'll throw out one more thing. Another way of writing this equation, sometimes it was already in slope-intercept form, but there's other times that it looks something like this. And we had to solve for y. Well, think about this. What does this mean? $2 for fries, $4 for double doubles equals $20. And if we went through and we solved, just like we solved for y, plus $20, and divide both sides by 2 and do that whole thing, you can end up with the same exact equation. F equals -2b plus 10. So yeah, $2 for fry plus $4 for double double adds up and equals $20. So maybe this will be a faster way, an easier way for you to get the equation. It doesn't necessarily say it has to be in slope-intercept form, and we'll be looking at this form more as we go along.